Today what we're going to be doing is we are going to be finding slopes, y-intercepts, writing equations to lines, and interpreting graphs in context. The directions say, give the slope and y-intercept for each graph shown below. Give the real-world interpretation of the slope and intercepts. Hint, be sure to look carefully at the scales on each axis. Write an equation y equals mx plus b that represents a situation. Use variables that have meaning to the graph and context. You replace the slope m and the y-intercept b. Number one, we are looking at pool passes. On the y-axis, we have cost of dollars, and on the x-axis, we have the number of passes. The slope can be found by finding the change in y. So if I choose 2 points, I can find my slope in y. My slope in y happens to be 6, and my change in x happens to be 2. My slope, therefore, is going to be rise over run, which is going to be 3 over 1. And we can just say 3 for our slope. Our y-intercept is where it crosses the y-axis. In this case, it's 6. Putting these two together, I know my equation will be y equals 3x plus 6. Now, what we want to do is we want to put the real-world interpretation of the slope. The real-world interpretation of the slope is pretty easy because if you look, we know that y is on top and x is on the bottom. On the y-axis, we have dollars. So what this is saying is that we have $3, and on the bottom, we have x, which is the number of passes. Now, the division sign can be read as per. So this means $3 per 1 pass. And this is my real life or my real world interpretation of the slope. So I know it's going to be $3 per 1 pass. So in other words, 1 pass costs $3. All right, number 2, the number of pizzas to order. We know the slope. We have to choose 2 points. I always kind of choose easy points when I can. My slope is rise over run. So I go up 2. And I go over 4. My slope in this case, if I reduce it, can be 1/2. We always want to reduce our slope when we can, so I have 1/2. The y-intercept is where it crosses my y-axis. In this case, it crosses my y-axis at 0. My equation will be y is equal to 1/2 x plus 0. Now, I don't need to write plus 0 because we know anything plus 0 is just going to be the number that it's being added to. So 1/2 x plus 0 is just 1/2 x. The real-world interpretation, all we need to do is we need to think about what's on the y-axis because y is on the top, x is on the bottom. On the y-axis, we have the number of pizzas. So we know 1 pizza. We know the division sign is per. And on the bottom, we have the x-axis. We know that's number of people. So 1 pizza per person. Per, not 1 person, but 2 people. So I should say 2 people. So there's 1 pizza per 2 people. One pizza per 2 people. On our next one, number 3, the cost of birthday cake. We have the cost on the y and the number of savings on the x. If I do my slope is going to be rise over run. So I go up 20 over 16. If I reduce this, I know 4 goes into both of these. So 20 divided by 4 is 5. 16 divided by 4 is 4. So I have 5 over 4. Now, if we use the same rationale that we used for the first 2, then what we are going to say is that $5 per number of servings, per 4 servings. Now, if you look at that, that doesn't really make too much sense. $5 per 4 servings. So what we want to do is we want to reduce this, and we know 5 divided by 4 is going to be $1.25. So I can say $1.25. And I can write $1.25 as a fraction by saying $1.25 over 1, but this is $1.25 per 1 serving. So $1.25 per 1 serving. I know my slope is 5/4. I'm going to leave it as a fraction. I know my y-intercept is 0. My equation will be y is equal to 5/4 x plus 0, which we don't include. My real-world interpretation is that it's going to cost $1.25 per one serving. On my last example, cellular phone plan, I have the number of minutes on the y and the days of the month. So my slope is going to be, we know it's going to be negative because it's going down from left to right, so I can put a negative sign in there. It's going to go down 20 and over 4 and 8. So I'm going to have negative 20 over 8. Now this reduces to negative 5 halves. If I look at this, this would mean that I have negative 5 minutes per every 2 days, per 2 days. Now, it's not the best. And if we want to look at it, we probably want to look at this as a decimal. So 5 divided by 2 gives us 2.5. So I can say negative 2.5 minutes per day. And that's probably a little bit better than saying, hey, negative 5 minutes per 2 days. We want to say negative 2.5 minutes per day. So I have negative 2.5 minutes per day. My slope, I'm going to leave right as a fraction, 5 halves. My y-intercept crosses at my y-axis at 60. And my equation will be y is equal to negative 5 halves x plus 60.